So the way we do it is we design our own sensor, and our sensor can send specific probe signals that can travel through the body rather than just stay on the surface.
We're with Yutian, nickname is Sit, and her company is BioMindr. She is the founder and chief technology officer. And Sit, I was wondering if you could tell me, we're familiar, wearables are becoming the rage. Everything is wearables, and perhaps most people are familiar with Fitbit. Well, you're doing something different. You're doing multiple things all at once. So tell us, what does your device do?
So we know about Fitbit. So what is Fitbit? What they do is they aggregate different sensors in one device, try to make a wearable device. And we think differently. We want to develop our own sensor using one sensor only to extract different biosignals. So that way the sensor can be integrated into different wearable format and at the same time generate different biosignals.
Fantastic. So let's break this down a little bit, because I'm not even sure I understand what biosignals refer to. So we're putting on something on our wrist, and then the device that's on our wrist, it can pick up what's going on in our body. Is that right?
Exactly. So when we talk about general biosignal, you're always talking about you have an external probe that's going into your body. Let it be optical sensor, let it be chemical sensor. You have chemical labels that can pick up information of your body. So the way we do it is we design our own sensor, and our sensor can send specific probe signals that can travel through the body rather than just stay on the surface. In that sense, we look at a bigger sample size that allow us to have access to the blood vessel inside. And in that way, we can do the chemical analysis information from the blood instead of just rely on the skin or the sweat. It gives us a bigger sample size. So we're looking at something different.
Great. So you put it on your wrist, and then it's starting to read what's going on in your body. Is this painful?
It's not painful at all. We're talking about radio waves. That's already existing in many devices, such as Wi-Fi devices, Bluetooth. It's all radio waves that we're generating. We're basically living in a radio wave environment. The way we do it differently is we introduce a directional radio wave that's actually specific to interface with human body. And then we extract information from them.
So that's pretty cool. So you're using the same radio waves that we broadcast communication to learn about the body. And what are the different things that your device can learn about the body? What are you tracking?
So we're starting from tracking just water molecules because it's the most abundant molecule in the body. And we build our own sensor and a data acquisition system to the interface. We even run through 3 clinical trials up to now with McGill University. And we're looking for a publication in this domain as well to provide people a validated device that can read hydration level. So right now we can achieve about 1% accuracy, measure hydration when they're doing exercise. And for glucose and sodium, we're still at the lab stage. So we're able to measure physiological samples with high accuracy, but to move it to human body, we still need to do some clinical trials.
Right. So right now you're really accurate in telling me what my water is.
Level. Yeah, hydration level.
And that's essential. So if I'm out running and I haven't drank enough water, or if I overdrank, your device is going to tell me.
Exactly. Myself, I tried to participate in the half marathon, and my co-founder is a professional athlete as well. So we do those endurance exercise. This summer I was doing training on myself, because I control my body using willpower. I know I'm thirsty, but I don't want to disturb my pace, so I keep running, and I end up with a heat stroke. So it's very important to know when to stop, just take a sip, and keep moving on. Also, when you're drinking, not to overdrink, but just the right amount. So it seems very trivial, but important.
Right, no, definitely important. So you're really good at that. You mentioned 3 things that you do, but when I look at your chart behind you, it looks like you have 5 different things: hydration, blood sugar, pulse, blood pressure, and sodium. Is that right?
Yeah, that's right. So using our app, where the signal we introduce called radio wave frequency. So using RF, we can detect two categories of signals. One is like chemical information of your body. That we're talking about water molecules, sugar molecules, and sodium ions and other ion species. And the other is the internal motion, like pulse rate, you actually see the motion, and blood pressure, that's also related to your pulse. And we're using a different concept, but the same sensor technology. So it's all about how to extract the signal, do the signal processing, and apply the algorithm.
Sure. Well, to me that sounds remarkable, because if you know anybody that has diabetes, you know, the process of going and pricking your finger to take a blood sample and a reading, what you're basically saying is you don't have to do that anymore. You can just wear this device like a bracelet, and it will tell you your blood sugar level any time. Is that right?
Well, it's not the exact blood sugar level we're aiming at right now. It's more like a relative change. So instead of telling you exactly you're at this level, using our technology, it tells you you're going up or you're going high. How can you track yourself while you're taking food intake, that you don't overeat or you don't like starve? Yeah, it's more like a relative change rather than the absolute value.
So basically something that you can watch while you're eating and after a meal to see if you've eaten too much or too little?
Exactly. So it's like a relative change on your personal base rather than the exact chemical measure.
Well, that sounds remarkable. I was wondering, where can our viewers go if they want to read more about your device and also keep track of when it's going to be available?
So we have a website. It's accessible. It's BioMindr.com. We also have a Facebook and a Twitter account and LinkedIn as well, that we publish articles about our progress, about our exposure, about collaborations with different university partners, and about how our IP is going when it's went public. So, and also, since we do a lot of collaboration with universities, we will have like medical journals as well. You probably will see our name appear there somewhere in the footnote or acknowledgement.
But it sounds like the easiest is just to go to your website and your Facebook page?
Yeah, the easiest one is the website and Facebook, because then you know the most friendly, easy to read information.
Great. Well, thank you so much, and good luck with everything. It looks like you're on the verge of doing something that's really different than what others are doing.
Yeah, and the vision we have is really trying to build a community, because what we're trying to do is to introduce this new sensor to unlock new data. So we know the data science is booming, and data eventually, hopefully, people with certain knowledge can give good feedbacks when they know certain data. And the feedback can be really useful for the general public.
Great. Well, thank you so much, and good luck with everything.
Yeah, thank you so much.
I'm Matt Peak with the Tech Ranch, CES 2017.